Okay, hello Algebra 2 students. Appreciate you getting time to get your notes taken care of. Today we're going to be looking at a little bit of the information we've been talking about as far as direction on our axes. Okay, what we're going to see today is that some of it we have been deliberately interpreting incorrectly. I apologize for kind of taking you down the wrong road, but there was enough stuff that we were already confused about already. I did not want to add this into the confusion until we had a better understanding. Now that we understand the equations a little bit better, now we need to get one of the things fine-tuned here. So the title is Interpreting the Axes Correctly. Our objective is the student will discover the true behavior of graphs when the variable under the radical has its sign reversed. As always, press pause anytime you need more time to copy stuff down, and then hit play when you are ready to move on. Let's begin. Okay, in recent days, we have been looking at graphs that have been doing a lot of various things. Their vertices have been moving around, they've been changing directions, changing speeds, and all that kind of stuff. So hopefully you've got a real good grasp of how to determine the vertex, the x direction, the y direction, the speed of a graph, all that kind of stuff. Okay. Now some of the information that we learned was this. Okay, we learned that reversing the sign of the radical was like reversing the direction of the isolated variable. Okay, which is to say that when we reverse the sign of the isolated variable, we don't actually reverse it over there on the left side of the equation, right? Because y is isolated in these cases, so we wouldn't put a negative over there with y, because then the y would no longer be isolated. So the better place to locate it is in front of the radical on the right side of the problem. And we saw that when that happened, that reversed the sign of the variable that was isolated. So in this case, y is reversed. Instead of the graph moving upward like the one on the left-hand side shows, the graph moved downward like the one on the right-hand side shows. Okay. However, many of you have been quite cleverly using the calculator in order to verify your results. Okay, so you've been looking at some equations and looking at some answers and things like that, and then typing the equations in the calculator, and then kind of using the grapher as a backup, a double checker, to let us know if we are responding correctly or not. Okay, and those of you that have been using the calculator have been discovering a bit of a discrepancy, okay, with this idea if the variable under the radical is reversed. Okay, so let's look at the same situation. Okay, again, the equation y equals the square root of x minus 2 plus 3. If we wanted to send this guy the other direction on the x-axis, we have been switching the sign of x. Okay, but comparing that equation to the graph, look at what the graph did. True, the graph is heading the other direction on the x-axis now. It's coming to the left rather than to the right. However, the vertex got repositioned as well. And if we're trying to keep the vertex in the right spot, then this is a big no-no. Okay, we have done something to the equation that has caused it to alter itself in a way that we had not intended. Okay. So, what we are seeing there is reversing the sign of the variable that is underneath the radical. It did not only send the graph the opposite direction, which is what we had intended, but it also repositioned the vertex. Okay, and it did it basically by this. It didn't just send the graph the other direction. It reversed the signs, all of the signs, dealing with that graph for that variable. So in short, what we're saying is this. Okay, by changing the equation from y equals the square root of x minus 2 plus 3 to y equals the square root of negative x minus 2 plus 3. One of the things that we did is we caused the graph to follow the x-axis in the opposite direction. I'm missing something in that statement there. I guess we should have said the negative x-axis. Apologize for the error in my notes. Okay, we didn't just make the graph follow the negative x-axis. We also switched, okay, all of the x value, the values from this equation. Okay, so it did accomplish what we wanted to accomplish, but it also accomplished more than that. Okay, so what's the big deal? How does this actually change things? Okay. Well, in addition to the direction change, the x value of our vertex changed its sign as well. Because like we said, since we changed the value of x, it basically went into that equation and it altered everything that associated with x. Okay, so if the goal is to reverse the direction and get the vertex position correctly, we are going to need to make an adjustment. And that adjustment is basically going to happen like this. Okay, so step by step, we have come to expect our equations to look like this, to follow this format. Y equals the square root of x minus h plus k. However, we have discovered the need for being able to reverse the direction of the variable that is underneath the radical. So in this case, we're talking about the x. The x value needs to have its direction reversed. However, we said that that also causes a change in the h value because it's not just the x direction of the graph, it's also all of the x values of the graph. Okay, so we're going to need to move the vertex back to where it was supposed to have been. Okay, and by doing that, we are going to have to change the sign of h. Okay, so the value h is going to change its sign because of the reversal of the direction of the x-axis. Okay, so in summary there, you have to reverse the sign of that part of the vertex as well. Now, basically, the easiest way to think about this is to not necessarily just consider that changing the sign of the variable under the radical sends the graph the other direction. Actually, what it does is it causes a complete reflection across the opposite axis. So if we change the sign of x underneath the radical, that actually reflects the entire problem through the y-axis. Okay, so we have to basically translate the vertex back to where it was supposed to be. So that means getting off of the negative axis and back to the positive axis. Now, the same procedure, which may sound a little confusing at this point, okay, it is also true for the inverse of these equations if we ever happen to bump into them. Okay, if you start off with a square root function that is x equals the square root of y minus k plus h, okay, if the value, the y-axis wants to be reversed, that is fine, but you are going to have to translate the vertex back across the x-axis so the vertex will be correct. So if it's minus y, then the equation is going to have to change to plus k to get the vertex positioned correctly. Again, it wasn't my intention to force you to learn it incorrectly or anything like that. It was a hard enough thing for us to figure out this direction idea and the vertex idea all at the same time. I did not want to add one more little complicating piece of information along with it, so I figured we would just kind of get the basics down and then we would be able to make this adjustment afterwards. All right, so let's look at some examples, make sure we have a grasp on this. Okay. Here is an equation of a square root function, obviously. And let's see if we can figure out what's going on. Where is the vertex of y equals the square root of negative x minus 1/4 minus 2/5? Well, this guy is obviously going the opposite direction on the x-axis. Okay, our parent function is supposed to go up and to the right. This one is going up and to the left. However, we need to move the vertex back to where it is supposed to be. Okay, so in our answer, okay, we're going to go h comma k. Well, our value h is 1/4. The sign that is in the equation shows minus. Okay. Now, what we have typically done is we said, okay, the equation is supposed to be a minus, x minus h. Well, the minus is there, so that would mean that the 1/4 is positive. However, because of the axis change to x, we must reverse the sign of that 1/4. So instead of the 1/4 that we typically would have said, we are going to change its sign to negative to make sure that the vertex comes back across the y-axis to where it should have been. Okay, and the k value should not be changed by any of this information that's going on. So it should say plus a constant out there for k. It says minus. That means that the value is negative, and the value is 2/5. Okay, until you get a better grasp of this, you might want to consider typing it in the calculator. And let's make sure that our signs are at least putting our vertex in the correct quadrant. Okay, but that is not to say we should just go to the calculator to get the vertex out of it. Use the calculator to verify that you got it right. And the reason you need to not use the calculator to answer the question for you is you might have an equation that the calculator cannot handle, like this one. The calculator cannot deal with the inverse of this function. It does not know how to graph anything that says x equals. Okay, so let's see if we can't find out where the x equal or the vertex is on this one. Okay, so once again, we're going to be looking for h comma k. Let's see what we can figure out. Okay, we have a -4 as a coefficient, but that does not change anything. That deals with the speed of the graph. Okay. Now we can see that our h value is a 2. There's a minus sign in front of it. That is supposed to be there. We see that we have a 4 for a k value with a plus sign in front of it, and that is supposed to be there. Okay, but now we need to ask, is this a situation where you need to do this translation? Do we need to push the vertex back across the axis or not? Okay. Well, is this graph going the opposite direction that it's supposed to? Okay, look at the variable underneath the axis right there. It is a positive y. Isn't it supposed to be a positive y? Yeah, it's supposed to be a positive y. So this thing has not been changed as far as its direction is concerned. Okay, so here's our k because it's attached to a y. Here's our h because it's attached to the x value. Okay, so it should be a positive 2k. It should be a positive 4h. And there it is. So this one was as close to a trick question as we could probably come by because it didn't actually change the axes. Okay, let's take a look at one more, and then I'm going to leave the last one to you. Okay, where's the vertex of y equals 3 times the square root of -x plus 1 plus 2? Okay, so let's take a look. This one is going the opposite direction on the x-axis because of the sign change underneath the radical. Okay, so we got to be sure we adjust the vertex correctly. Okay, now k sitting out there, nothing is going to affect it. It's supposed to be positive, and it is positive, so our k value is a 2. Okay, now the value underneath, the h value attached to x, okay, the problem is supposed to say -1, but it doesn't. It says +1. So that means 1 has a sign change attached to it. So we are thinking about the possibility of a -1. However, because of the direction change on the x-axis, that means we have to move this vertex back across the y-axis and put it back where it goes. That means we need another sign change for the 1. It'll be a positive 1, comma 2. I'm going to leave the final one to you to answer. Now, please remember, this one is an inverse. It is x equals, and it's all to do with y. So that means that this guy right here, that is your k value. This guy over here, that is your h value. Be sure to remember that when you are coming up with your vertex. But let's see if you can find the vertex of this equation. I will see you in class.